So in this video, we're going to talk about rules for multiplying and dividing fractions. This is super important. You have to know these. Absolutely have to know these. So just do practice problems until you got them down cold. So a over b times c over d equals ac over bd. You just, when you're multiplying two fractions, you just multiply the numerators and multiply the denominators. Don't do that if you're adding. Just multiplying, okay? So that's, and the restrictions on that, I think we just learned, is that b, you can't have 0 in the denominator. So b can't be 0 and d can't be 0, okay? ab over cb equals a over c. The b's reduce. That's from, remember the lecture 0. The b's reduce because b over b is 1, and a over c times 1 is a over c. But notice this is kind of a strange thing. I've got a over c, and I've got c not equal to 0, but I've also got b not equal to 0. Why? Because the original expression has a b in the denominator, and that's what determines the restrictions on the expression. So if I want to know the restrictions here, you can't have c not equal to 0, because then ac would not equal ab over cb, because ab over cb would be, well, neither one would be a real number. So they're just nonsense. You could say nonsense equals nonsense, but they're not necessarily the same nonsense. Hard to explain that. Reciprocal of a is 1 over a, where a is not 0. Use this mostly for integers and polynomials. Reciprocal of a over b is b over a, right? If you have a fraction, you just do the reciprocal. You flip the numerator, exchange the numerator and denominator. And for this, you can't have a equals 0 or b equals 0, because in one fraction, b is the denominator, so that b can't be 0. And in the second fraction here, right, the second fraction, so the first one, the b can't be 0. And this one, the a can't be 0. So you need both of these. So I'm just doing the restrictions here for practice, okay? AB divided by c over, a over b divided by c over d equals a over b times d over c. So the way you divide two fractions, right, is you flip the one that's being divided, not the one that, this one here, the second one, the one after the division sign, always. So you do the reciprocal of that. So divide is, dividing by c over d is the same as multiplying by d over c. Okay, so you need to know that rule. And here, none of these denominators can be 0. So b's not 0, c's not 0, but also d's not 0, because of this one. Okay? So only a can be 0, because you can have 0 in the numerator, it's no problem. It just gives you 0. Now, I'm throwing in 2 terms in the numerator, 2 terms in the denominator. This situation comes up quite often, so I want you to recognize it when it comes up. All these you should know. That means if you have to memorize them, memorize them. If you can learn them by just using them, that's usually really good. So here I have a minus x over x minus a. So these are subtraction, but they're kind of the opposite, right? And so they actually are literally the opposite signs of each other. See, here a is positive, and here a is negative. X is negative, x is positive. So the bottom is just the negative of the top and vice versa. So what you do is just flip around this a minus x to x minus a and put a minus in front. Okay, and you can see that's right. If you distribute this minus, redistribute it, you get, remember, it just gets distributed in the numerator. So you get minus x plus a. And then if you flip those around, you get plus a minus x, which is just a minus x, right? So this is important to know why, because this reduces, right? Any number over itself is 1. So this is actually negative 1. So that's why you would do that. This is things you do not do. And I covered this in that lecture 0 because it's very important. C is not a factor of the numerator. It's a factor of the second term of the numerator. So you can't factor it with anything in the you can't cancel it with anything in the denominator, because a factor of the numerator cancels with a factor of the denominator. So, you know, this is bad. They do not cancel. That doesn't work either. I just realized I just crossed the C's on number 6 off again for some reason. Well, so on number 7, what did I do? I'm thinking to myself, the rule is if there's a letter in the top that's the same as the letter in the bottom, then I cancel. If you're thinking that, that's wrong. That's completely wrong. Oh, but I get some problems right that way. Yes, because sometimes it's like this one here. See, where there's just a single term on top and a single term on bottom. But with 2 terms, you got to be more careful. 2 or more terms. So this C does not cancel with this C for the same reason these C's didn't cancel, because C is not a factor of the numerator. You have to factor the numerator first, right? And you have to factor the denominator, and that would depend on, see, A, B, C, and D here represent some kind of algebraic expression. You know, maybe polynomials for this section of some kind. It could be constants, or it could be an x, or it could be 2x squared, like C could be 2x squared. Anyway, those don't cancel. The B's do not cancel. The D's do not cancel. You have to factor the numerator, factor the denominator, then cancel common factors. Okay? I did write the negative 1 in here eventually, right? So I just wrote out what I just said. No harm in repeating and no harm in having this written out in your PDF for review. So to reduce, the number or expression must be a factor of the whole numerator and the whole denominator, not a factor of one term in each, which is what happened here. This is totally wrong. I kind of put it in red to kind of, or pinkish red. Red on blue doesn't work too well, so I made it kind of pinkish. That's the warning. No. No. Okay.